This lecture is going to be our section over complex fractions. Complex fractions are usually, well, they're intimidating for a lot of students because even the word fraction, just plain old regular fractions, are things that students don't enjoy. But a complex fraction is even worse, might I say, because a complex fraction means that the numerator or the denominator of the fraction has more fractions in it. Now, our job and our task when we're faced with a complex fraction is to end up with a fraction in lowest terms, where there's no more fractions in the top or in the bottom separately. Okay, a complex fraction is not an acceptable form to leave a fraction, and so I need to leave it in a nicer format. Now, there's more than one approach, and your author shows both of them in your book. Most of the authors do, and the one that I'm going to show you here today, in all honesty, is the one that usually has more steps, but it's the one that students are more consistent with more of the time. So if you are curious about the other method, if you see it in your book and say, hey, what's that? You're completely and totally allowed to use it. I would be glad to work with you one-on-one if you want to ask about it, but it's not the way I'm going to show you in the video today. When we're looking at and when we're facing a complex fraction, the first thing that we want to do is narrow our focus. Okay, I'm going to fill that guy up, and we're gonna treat this fraction as three separate problems. Okay, first I'm to worry about the top on its own, and then when I'm all done with that, I'm going to come back and deal with the bottom. And then the very last thing I'm going to do is deal with the ratio that's left. So if I cover up the bottom and I don't focus on it at all, I say, well, I just watched a bunch of videos on adding fractions, and I feel pretty confident that I know how to do that now. So if I want to add two fractions together, I know that I have to find what? A common denominator. And if I have a plain old number like 1 or 2 or 10, I can write it as 1 or 2 or 10 over 1 if I need to. And the nice thing about these complex fractions is the denominators are oftentimes a lot nicer here than the ones we saw in the last section. I can't factor 1 and I can't factor x, so when I go to build my common denominator, I take the 1 and I take the x and I multiply them together. And no, you don't have to write the 1 on there. You can just call it x. So step 1 from the last video was factor denominators if possible. We did that. And then we built the lowest common denominator out of 1 times x, so we did that. The next step is to rewrite the fractions over that denominator. So I need an x on the bottom of this first one, and I can't put it there unless I also put it on top. So 1 over 1 becomes x over x. Notice the second fraction, 1 over x, is already over the denominator that I need. So that means I don't change it at all. Now, here's where a lot of students make a mistake, and I think it's just because you get in a hurry. But from here, I combine the tops, keep the bottom. If I combine x and plus 1, are those like terms? Please be shaking your head. Okay, and so if they're not like terms, I can't combine them into a single term. So the best I can do is take x plus 1 and write it as x plus 1. From here I would reduce if possible. This doesn't factor, x plus 1 doesn't factor, there's no x plus 1s on the bottom, so I'm done with the top to that step. Okay. So now I can ignore, hey look, that's kind of funny, we'll just slide him out of the way. Okay. When we come back and start with the bottom, I am going to do this, even though part of it's not covered. If I have 1 and x for my for my denominators again, then just like up above, I take 1 times x for that common denominator. Need an x on the bottom and an x on top here, so I get 2x. 3 over x is still 3 over x. I have that minus sign that I'm going to pop up next to it. Okay, it didn't hurt anything to leave it out in front this time, but sometimes it does, so I want to be consistent with my approach. Now when I add the tops, or combine the tops, keep the bottom, we get 2x minus 3 over x. 2x minus 3 doesn't factor. There's no 2x minus 3's on the bottom, so I'm in lowest terms for that bottom fraction. So we've done, I'm going to say 2/3 of the problem. We said we started with the top and did an addition problem and took it all the way to the far right. Then we came back and said I'm going to do the same thing to the bottom and ignore the rest until I need it. And we got over here to 2x minus 3 over x. Now the last thing I need to do is take care of this division. And division we did a couple sections ago, and I know how to divide. In section 6.1 in our book is what it was, we used the divided by sign like this when we were being asked to divide two fractions. Today it's going to be this division bar. But I know when I'm asked to divide two fractions, I keep the first one just as it is, and then I multiply by the reciprocal of the other. So when I flip that second fraction over and I turn it into a multiplication sign, then I can look and say, well, x divided by x goes away. Hopefully everything's factored for us in this step, which means we'll just have to come down, or it just comes down to the reducing step. So x's are gone. X plus 1 over 2x minus 3 is what's left. So they get a little bit more. They get a little bit more as time goes on, but this is the idea. We're going to do a couple more. I'll probably put them in a separate video just so they're smaller bites. But